Hello, everyone. I'm happy to be here today at the Microsoft Research Summit. My name is Julia Kiseleva, and I'm a researcher at Microsoft Research. I'm here to present and share with you our ongoing work on interactive grounded language understanding, which we position at the moment as a competition at NeurIPS 2021, so that we can attract as much attention as possible to this very interesting problem. And luckily, I'm not the only one who is doing all the work. This is a great collaboration among the institution as Microsoft, University of Amsterdam, Moscow Institute of Physics and Technology, and Facebook AI. And as you can see here, there's a lot of amazing people who are helping me and you to have an opportunity to participate in this competition. Let's move on to what we actually tried to study. So as machine learning and AI in general is making a great progress at the moment to build agents which can help us in our daily life. So we concern is actually how to build the interactive agents that can learn to solve the task provided grounded language instruction and collaborative environment. So what does it even mean? It means that we want to make an attempt to try to build the agents which would be able to understand human instructions in a natural language and assist human accordingly. And this brings us to two main research questions, which we'll try to approach in the course of this competition and following research. So first of all, how to teach. So besides the agents needs to follow our instructions, it's also important to understand how to provide those instructions to the agents. And the second one is how to learn, and that is mainly focusing on how to build the agents which were able to understand human language and being able to make moves based on that. And in maybe near future, I was also being able to give a feedback. So meaning that when instructions are not clear, the agent is able to ask a clarifying question. So what we're trying to achieve, we're trying to make a teacher who is able to take the complex task and decompose it in an instruction step, being able to answer the questions and being able to relate the performance. And for the student or learner or builder, as we call it in our competition, so that it's able to understand the environment it's acting on. So because the environment is not only natural language, but also it's built in some sort of imaginary game, and initiate some feedback and requests. But let's take it a little bit even closer. So in this competition, we try to imitate the collaborative game between, as we called, architect and the builder. In some previous literature, you probably have seen it as instructor and follower, but we stick to this terminology. So what is architect here? Architect is able to see the target structure, and he needs to provide the instruction. As you could see on the right-hand side of my screen, so the architect is asking builder to do some moves. And then if the instructions are clear, so the builder just can follow that. Or if instructions are not clear, the builder should ask a clarifying questions, as just human are usually doing that. Like if we don't understand something, we don't do things right away. We actually ask for clarifying question. So that's basically bring us to two tasks we're trying to solve during this competition. First is how to train the not the perfect, but at least some architect, which would be able to build to give an instructions by taking into account the target structure and ongoing conversations, and the builder, who is able to understand the instructions from the humans in a natural language, also being able to ground it in a game. So here we basically filled it as a game. So it's a sort of Minecraft environment, but we remove all the unnecessary complications as some background and just focus on the structure itself. And I personally love this task because actually give us, first of all, it's a collaborative task. So that's where the human and AI can collaborate together to build better things. And second of all, this task has a quite a non-subjective metric. Basically, if we would be able to build the structure as instructed, because we have a target, so the collaboration was successful. And when we are not able to do that, the collaborations are not successful. And that's very important to understand, because we know that most of the metrics we use, especially for the natural language, sometimes can be a little bit further from what humans actually expect to do. Let's look at that a little bit more closer. So architect is supplied with a target structure. And here you could see some examples of those structures. Some of them are quite difficult. So we do have different level of difficulties of the target structures to actually understand the limits we can reach at the moment. So architect, given a target structure, needs to generate the instruction for the builder at step 0. And then, given the past instructor builder conversation, generate the next appropriate instructions. And again, those conversations are embedded, or as we like to call it, grounded into the environment we work in, as you could see here on the pictures. As the input data, we provide a time step, a chart history, the builder position, the builder block inventory, the location of the block in the build region, and screenshot taken at each step. Let me tell you one more thing here. So there's initial data which were collected by our colleagues from UIUC University. Those data were collected when architect and builder were able to interact with each other online. However, this type of data collection is not scalable. So we actually bring this task into the mechanical Turk environment where we're able to scale it up. So we at the moment collecting we developed and continue developing and improving the pipeline for this type of data collection. And that is much more scalable because it does not require 2 people to be online at the same time. From the literature of our colleagues, we inherited the first baseline model for the architect task. Here is just a simple sequence-to-sequence model. And at the bottom of the slide, you could see the link to the paper where the baseline is explained. And in our starting kit, which you can download from our website, you could basically run this baseline model. So this is not a very complicated baseline model, but that's a goal. That was a goal to actually propose something relatively simple so that the participants have actually a way to improve this model. So, and we have 2, that's another very important step which we try to take at this competition. We have 2 types of evaluation. So as ongoing competition, so we will provide the automatic evaluation, and that's blue scores. That's what has been used in the literature, and that's what people understand. However, we are committed to provide a human-in-the-loop evaluation. The current idea is that the competition will be run till the end of November, and then the best solutions for 2 tasks will be used further with the humans. So basically, this step, like the architect, would be one of the developed ML models, and the human in a loop will be able to evaluate these tasks. So what's the builder task? Builder task is when the builder has access to the instructions which are provided by the architect, and it can see his previous steps and is able to see what has been built so far. And our data set is basically can be used as a demonstration for RL agent. So on top of that, we developed for this competition the environment, which you can also download from our starting kit. And this environment is help you to train your RL agent easily. However, we don't limit you only to build the agents using the RL. You could also see that we have a baseline released, which looks as a supervised learning. So we try to attract as many participants as possible with different backgrounds, because we believe that only if we approach the problem from different perspective, we could find the best solution. And here is just an example of the video rendered by our environment, and it shows to you how the agent is building the structure based on provided instructions. So sometimes blocks applies, sometimes blocks are removed. And as evaluation for the builder task, we obviously, as automatic evaluation, use a completion rate, success rate, and reward. However, the same way as for the architect task, after the main phase of the competition, we are going to arrange the round of human evaluation. So in this case, the instructions would be provided by human, and then the builder would be one of the trained ML systems, which would be our builder. And as I said, that would be depending on which one would be performing the best in offline manner, and see if this builders would be able to understand the human instructions and complete the task. So here is a brief introduction for our goals for this competition, and also the starting key which will be provided to you. So if you're interested, please join us and register for the competitions. You could see the link provided for the architect task, and you could see link provided for the silent builder task. Thank you so much for your attention, and I hope to see you best submission. Thank you. Bye-bye.